This is a short video about research design. Your book distinguishes between statistics and experimental design, and I want to put that in a little more context since they jump right in. Research design can take several forms. There are three main types, and you might find them with slightly different names, but these are the most common ways that people refer to them. We'll first talk about observational design. That's research that observes, measures, and records some variable or set of variables that of interest. And variables, again, are things that exist in more than one kind or form or more than one amount in the world. So in observational design, we're just trying to observe those, measure them, record the information. We don't change or alter or interfere in any way. In correlational design, we do the same thing. We are observing, measuring, and recording things that are already happening. However, in correlational design, our intent is to see how two or more variables might work together. Rather than just observing, we are setting out to see how things are related to one another or how they might be different from one another. So correlational design, again, we don't interfere in any way. The interference comes with experimental design. So in experimental research, we again observe, measure, and record things that are happening to see how two or more variables are working together or might be different. However, in experimental design, we manipulate some variable. And so we are looking to see how these variables work together because the researcher has manipulated a variable. And experimental design has this gold star of causality. That means that experimental design is the only way to indicate that things are causing something else to happen. So experiments are the gold standard of causality. You might have heard the phrase correlation does not imply causation. That's because finding that two things are related, that two variables work together in some way, does not tell you which one causes the other. To do that, you have to do an experiment. So let's dig in a little deeper to experimental design. In experimental design, we label our variables in certain ways. We have an independent variable, or IV. The independent variable is one that the research manipulates. That means that the researcher assigns different kinds or amounts to various subjects. So this could be something like which group you are in, and one group gets one treatment and another group gets another treatment. That could be an amount of a drug. It could be that one group gets no drug, they're the control group, or they get a placebo. That means they get something that they think is a drug, but does not actually have any of the active ingredient. And then you could have an experimental group that gets the actual drug. You could have multiple experimental and control groups. We could have a placebo control. We could have a no drug at all, just observing control. For experimental groups, we could have a low dose, a high dose, a medium dose, however we want to do that. This could also be designs where we actually do something in the environment. Maybe we show them a video, maybe we ask them to do physical activity. So whatever it is, we have assigned different kinds or amounts to different groups of subjects. We are doing that to see if that variable that we have manipulated has an effect on the dependent variable. The dependent variable is the one that would be changed by the independent variable. And so for the dependent variable, the DV, the researcher measures it to look for evidence of change from the independent variable. And so we would carefully measure the dependent variable and compare across the different independent variable groups. We can also have variables that cause problems, right? Those are called extraneous variables. You also will hear them called confounds or confounding variables. These are other things that could be having an effect on the dependent variable as well. And it can make your results very hard to interpret. So if we are trying to do a study on heart rate and see if whenever you are nervous, say because you are about to give a speech to a large group of people, if nervousness increases your heart rate, it does. But we're looking to see if our task of public speaking is going to do that. And so we get people ready to give a speech, but in the process of doing that, we have one group that's going to give a speech to people and they are in one room. We have another group that we're just having them do a similar task. They are writing a short essay. They are never told they're going to have to read it to any group of people. And so we want to see how their heart rate might change during this writing task, knowing that they're going to have to speak or not speak. In that situation, it is very important that their environments be as similar as possible. What if, when we had our group that was about to give the talk to actual people, the room was very hot? In that case, it would be hard to know whether the room temperature or whether the task was actually causing the effect in the dependent variable. So in that case, room temperature would be an extraneous or confounding variable. We would not be able to say for sure that our task was what was causing the change in heart rate. And so we want to control extraneous variables as much as possible. We want to make sure that each of our groups, each of our levels or conditions in our independent variable have the same environment. And the way that we tend to do that is by mixing up, which room they're in or what time of day. We try to make as many things as possible the same. We try to measure as many things as possible to control these. And so you want to plan for extraneous variables, all the possible extraneous variables that can pop up before you ever begin collecting data, so you don't waste your time and your subject's time. So we'll stop there and we'll be revisiting this the whole semester. Thank you.